Hello guys to a new lecture about Kubernetes and Helm by practice. Today I am here to create a deployment using Helm chart. So in real life we have a lot of file, so we need to organize this file in archive. In the IT world it's the same, and our Kubernetes deployment file is the best example. As you can see, we have a lot of file: backend ingress.yaml, backend service.yaml, backend YAML, Mongo persistent volume claim, etc. As I mentioned in the previous lecture, to install the list of dependency or the list of Kubernetes object manifest, we need to follow this order. As you can see, we need to install at the first part the persistent volume, next the persistent volume claim, the deployment, and the Mongo service.yaml. And for the backend part, we need to install first of all the backend YAML, the backend service, and finally the ingress. So before Helm, to install any Kubernetes manifest object, we need to use one of the three methods. The first method is using REST API, the second is to use Go client, and the latest method is using kubectl. But we have a difficult to match this order. For example, to match this order, I create install.sh to understand which one is the first, which one is the second, etc. Also, with Kubernetes, we can manage the version of deployment using rollout and rollout endo, but we can't manage the version of our deployment. I mean that we can't manage release, and we can't manage the same release for different environment like development, staging environment, and production environment. So for that we need a package manager to manage all this. A package manager is the responsible for installing, upgrading, switching from a version to another version, etc. And the package manager here for Kubernetes is Helm. We think that Helm is like other dependency management. For example, for operating system, we can think Helm like RPM for managing package, for package manager for Red Hat, apt as a package manager for Debian, and for programming language we can thinking like Node package manager for Node.js application, Maven for Java application, Pipe for Python application. So we need to understand the architecture of our Helm release. We need to understand how Helm working. We have two versions of Helm. The first version is the version 2, and the second version is the Helm version 3. To recap, Helm 2 is a client server architecture with the client called Helm and the server called Tiller. As you can see, we have Helm client here and Helm server Tiller installed in the Kubernetes cluster. The client is a client that user interact with it to perform different operations like install, upgrade, and delete. As seen in the following diagram, the client interact with the Tiller and the chart repository. Here, like Git repository or Docker repository, we can pull and push charts. Tiller interact with the Kubernetes API server. It render Helm template files into Kubernetes manifest file, which it used for operation on the Kubernetes cluster through the Kubernetes API. The second version of Helm, Helm 3, has a client-only architecture with the client still called Helm, but the Tiller or the Helm server is removed. As seen in the following diagram, it operates similar to Helm 2 client, but the client interacts directly with the Kubernetes API server. The in-cluster server tiller is now removed. The main benefits of removing tiller is that the security is now on per user basis. It's delegated to Kubernetes user cluster security. Access to the cluster using Helm 3 is similar to kubectl. Let's go back and let's understand how the project structure or the folder structure of our Helm. But before that, we can go and let's check how to install Helm. To install Helm, go to the Helm website and you can download the desired version of your Helm using tar to unpackage or to decompress your tar, and finally copy your binary to user local bin Helm. As you can see here, Helm is installed in my laptop, and now let's create the first chart. So go here and go here, new terminal, and Helm create Python app. As you can see, our chart is created. So as you can see here, we have a folder called Python chart, and we have two folders. The first folder is chart, the second is template, and we have three files: values.yaml, chart.yaml, and helm ignore. The first folder is a chart. This is an empty chart for the moment because this chart contains all the dependency that we need for our package. For example, if we have a backend application, maybe our application depend to install a database or a Redis cache. So we need an external chart that we can load statically from this chart or dynamically from the chart.yaml by adding here the list of dependency or the list of chart that depend to our application. After loading the list of dependency, we have two methods: dynamically from the chart.yaml or statically by downloading the chart and put it inside the chart folder. We will move quickly to the next step is to understand what is the template folder. Template folder contain all the Kubernetes manifest YAML that we need to deploy our application. For example, if we have here in our deployment folder this deployment files, we will copy all this deployment file from the deployment to the templates folder. We will try this together after explain this folder. After that, we have a chart.yaml. The chart.yaml is a file that have the list of metadata about our chart and our release, like API version, the version 2, the name of our chart is Python application, a description, a Helm chart for Kubernetes, the type for application, the version of release, and the API version. Also, to make our chart customizable, we need to insert a list of value inside values.yaml. So values.yaml have a list of key value to customize our charts to be deployable in different environment like dev environment, staging environment, and production environment. So as you can see here, we can control the number of replica, the image, the service account, pod security, the cluster, ingress, etc. etc. So we have a list of template. So we have a list of command to manipulate charts and release in our Kubernetes cluster. So first of all, what we need is to copy all this file from the deployment folder to the template test folder. So task Python deployment, and we will copy all this file and go here, Python application charts, templates, tests, and paste all this file here. Test connection YAML, we don't need this again, delete. And after, just go here and using Helm template Python app and specify the values -f Python app values.yaml and insert. And as you can see here, we have the list of files that we have in the first step. As you can see, it's a service account for our Python application. After, we have a persistent volume for our Mongo persistent volume. Also, we have a persistent volume claim for Mongo persistent volume claim. Then we have a service for release name. We need to make the version or the release name here. Let's go and let's call it backend, enter. And as you can see, now the release name is modified by the name backend Python application, etc, etc. So as you can see, we can make all this like here for dev.yaml, and as you can see here, this is our file dev.yaml. Let's put to the right, and as you can see here, this is our file dev.yaml. We have persistent volume for Mongo persistent volume, also persistent volume claim for Mongo persistent volume claim, also the service, the port, the target port, the type is a cluster IP. Also for templates test backend service.yaml, we have a service for our application, for our Flask application, also for the service for Mongo, also here the deployment for our application or for my Python application, Nginx, etc, etc. So to install this, just we go here, we need to specify the namespace. So we need to create a new namespace, Helm release, and now just with Helm install to install this. Install backend Python application -f and -n and the name of our namespace. Enter. As you can see, our application is deployed successfully, and what we need is just to verify the list of Kubernetes objects. So and as you can see here, we have 3 pods, 3 service, 3 deployment, and 3 replica set. And we can also view the history of a release, and as you can see here we have one release in the namespace Helm release called backend, and the Helm release is the API version, the name chart, etc. So this is all about how we can deploy Kubernetes manifest using Helm, and in the next lecture you can customizable our deployment by customize the file values.yaml. Thanks for watching. Don't forget to like and subscribe, and see you in the next lecture. Bye bye.